So here in this one, we're given that secant theta is equal to 4. This is one of the reciprocal trig functions. If you're given a reciprocal trig function, you can always find the primary trig function that goes along with it. So if secant theta is equal to 4, you know what cos of theta is. We just take the reciprocal of the answer. So the ratio here is 4 over 1. So cos will be 1 over 4. Now in part A it says we want to determine the exact values of all the other trig ratios. So not only do we want to find cos, we also want to find sine and tan. We'll do those ones in blue, and we want to find the reciprocal functions that go with those ones. So that's cosecant and cotangent. In order to do that, we need to draw a triangle. And we need to draw that triangle in the right place. So this one says we're looking from 0 to 180 degrees. And in order to figure out where your triangle is going to go, you're going to look at your cast rule. So according to my cast rule, cos, which is 1 over 4, which is positive, that can happen in quadrant 4 or quadrant 1. But we're only looking from 0 to 180 degrees in part A, so that would cancel out those ones. You would only look in quadrants 1 and 2, and since cos is positive, it has to be in quadrant 1. So one of the first things that we're going to do that's going to help us, we're going to draw our quadrants, and we're going to draw our angle. In this case, it's in quadrant 1. And once we have that angle, we can make a triangle to the nearest x-axis. Again, always to the nearest x-axis, because this angle is your reference angle. In this case, it's your actual angle as well, because in standard position in quadrant 1, your reference angle and angle are the same. But we'll always label it as a reference angle to start. And what do we know about this triangle? Since we know that cos of theta is 1 over 4, and cos is your adjacent side over your hypotenuse, we can label this side as 1 and this hypotenuse to be 4. So our cast rule reference angles allow us to draw that triangle, and once that triangle is drawn, now you can do a squared plus b squared equals c squared and calculate the other side. So I know my hypotenuse, so I'll go 16 minus 1 is 15. This side will be the square root of 15. Now that all the sides of that triangle are labeled, you can finish up our primary ones. Well, we know that sine is the opposite over hypotenuse. We can now look at our triangle. Sure enough, we know the opposite side, we know the hypotenuse, so sine will be square root of 15 over 4. We've got tan. Tan is opposite over adjacent. You wouldn't have to write that over 1, but I'll do it at this time because it's going to help us with our reciprocals. So we figured out our 3 primary functions from the triangle. And then to figure out the reciprocal ones, well, if sine is root 15 over 4, cosecant is going to be 4 over root 15. If tan is root 15 over 1, cotangent is going to be 1 over root 15. Since that triangle's in quadrant 1, they'll all be positive. Because according to our cast rule, sine, cos, and tan are positive. And wherever they're positive, the reciprocals, when you flip the fraction, it's still going to be positive. Doesn't matter. Because the original fraction was positive, flipping the fraction would still be positive. So we have found all the other trig ratios for that. Now in part B, now they want us to find the angle. And with finding the angle, they've also changed the domain. They said, now look between negative 360 to 360. So what does that mean? Well, here in part B, again, according to my cast rule, we already know we could have a triangle with our reference angle in quadrant 1, and we labeled this as 1, 4, and square root of 15. But now that we're going from negative 360 to 360, that's going to include all 4 of our quadrants. So earlier, we also said there's a possibility that that angle could be in quadrant 4. Right? Can you see up here from before? If now we take away this, cosine is positive in quadrant 1 and quadrant 4. This was the information that we were given right from the beginning. We were given this, and so we knew this. These were the 2 pieces of information that we were given from the beginning. And because of those 2 pieces of information, because cos is positive, we know it can either be in quadrant 1 or in quadrant 4. In part A, we didn't have to worry about quadrant 4 because it was outside of our domain. But in part B, we do have to consider quadrant 4. We would still have the same reference angle. Everything could be labeled the same on this triangle because cos is 1 over 4. But we have to consider this one because if we really think about what does what does negative 360 to 360 mean? I'm going to draw a little picture of it here. I'm going to use 2 different colors. What I like to think about is if we have angles in standard position, they always start from the positive x-axis where we have 0 degrees. So when I'm thinking about negative 360 to 360, does that make sense that it goes from negative 360 to 0 and then 0 to 360? That's what negative 360 to 360 means. So when I'm thinking about angles in standard position, since they always start at 0, well, once around the positive way, that would be from 0 to 360 degrees. And once around the negative direction, that would be like starting at 0 and going to negative 360. And so when we're trying to solve this question from negative 360 to 360, we're really thinking about going from 0 to 360 once around in the positive direction, and going from 0 to negative 360 once around in the negative direction. So let's think about the positive direction first. I'll keep the colors the same. Can you see that I would hit this one with that standard angle? And here I would hit this one with that angle. In the negative direction, if I started here, I would hit that one with that angle. And here, if I started at positive x-axis, went in the negative direction, I would hit that one there. So to solve this question of where is this answer between negative 360 and 360, we're going to get 4 different answers for theta. 2 positive ones and 2 negative ones. But the key to figuring that out is going to be solving our reference angle. And solving our reference angle is just a matter of looking at the triangle and say, I want to find that angle. I want to find that reference angle using grade 10 trigonometry. Looking at the numbers, and the fact that we were given this already, we know that cos of theta, or even I can label it, because I'm actually thinking about that triangle, cos of my reference angle is 1 over 4. If I wanted to find my reference angle, I would go to my calculator, I would type in cos inverse of 1 over 4, and 75.5, I think it asked for the nearest degree, so we'll round that to 76 degrees. So we can find our reference angle, and once we have that reference angle, we can solve for our actual angle. In quadrant 1, does it make sense that your actual angle is exactly the same as your reference angle? So one of our answers is 76 degrees. In quadrant 4, does it make sense that this angle will be 360 degrees minus 76? Because if this is my reference angle, I could go all the way around, which is 360, subtract 76, and I would get the answer that's left, which is 284 degrees. If we now think about our negative angles, can you see, I'll start with the one in quadrant 4. Can you see that this negative angle is exactly the same as the reference angle? It would just be negative. And this angle in quadrant 1, sometimes when I'm thinking about my negative angles, I think about my negative angles the same way I solve my positive angles. And in fact, if you're going to quadrant 1, in a negative angle, it's like going to quadrant 4 in the negative direction. So if I was finding this out in the positive direction, what did I do? I said, oh, I'll go 360 degrees because that's all the way around, and then I would subtract my reference angle. That's what I would do in a positive one. So I'm going to do the same thing with the negative angle, but once I get my answer, I'm just going to put a negative out in front. And can you see that that's also going to be 284 degrees, so our last angle will be negative 284. So in these questions, we're going to have to think about our domain. What does the domain mean? And I like to break it up into positive angles and negative angles, especially these ones that overlap. And in this case, from negative 360 to 360, well, that would include my positive angles from 0 to 360 and my negative angles from 0 to negative 360. Use my cast rule to figure out where my triangles are, what quadrants they're in, draw pictures of them because it really helps us see what's going on. And then we can see, well, there's going to be 2 positive angles and 2 negative angles. Use your triangle to find your reference angle. Your reference angle will always be positive. And then once you have your reference angle, use your pictures to help you figure out what the answers are in the end. Questions 9, 10, and 11 for practice.